Good day, everyone! I am Juliet Tawakal Manalao, your learning facilitator for today. I have here pictures of an old ways on how to measure an object. What picture is this? Very good! It's gantangan. A gantangan is a vintage grain measuring box. How about this one? Very good! It's takal! A takal is a Japanese term. Let's have another picture. How about this one? What picture is this? Very good! It's mangkok. It's a bowl in English. How about this one? Very good! It's basket. And in Visayan, it is called bukag. What are the uses of those objects? Today, we will discuss on how to get the volume of an object. But before we will proceed, let us have this pretest. Below are different kinds of solids with indicated measurements. Identify the units of measurement of volume used in each figure. Write your answers on your notebook. The first one has been done for you. You have 2 minutes to answer the questions. Thank you. Time's up. Let us check your work. And number 2, the unit of measurement of volume used is cubic centimeters. Number 3, it's cubic decimeters. Number 4, it's cubic centimeters. Number 5, it's cubic millimeters. Who got the perfect score? Very good! Let's have another exercises. Find the volume of each figure. For cylinders, let pi is equal to 3.14. You have 3 minutes to answer these questions. Write your answer on your notebook. Let us check your work. For number 1, the correct answer is 36 cubic centimeters. Number 2, the correct answer is 80 cubic centimeters. And number 3, the correct answer is 401.92 cubic centimeters. For number 4, the correct answer is 706.50 cubic centimeters. And for number 5, the correct answer is 125 cubic centimeters. Who among you got the correct answer? Congratulations to those who have answered correctly all the numbers. But to those who don't be sad. This lesson is for you. What is this module about? Water is very important in our lives. But right now, the supply of water is becoming more scarce every day. That is why everyone must learn to conserve water. Many people store water in rectangular or cylindrical tanks. Others store it in plastic cylinders. How big are the water containers that you see in your community? Some of them are big while some are small. Can you estimate the volume of the tanks that you see? In this module, you will learn more about volume. In this module, you will learn what volume means. You will learn to identify the standard measures of volume. You will read and record the volume of different solids. You will also solve practical problems in computing the volume of rectangular solids, cubes, and cylinders. You will also learn the indigenous measures of volume. By volume, we mean the amount of space any form of solid or liquid matter occupies. Let's study the figure below. These are wooden blocks piled on top of one another. As we look at the top layer, on the shorter side or width of the picture, we have 3 piles of blocks. On the longer side or length of the picture, we have 6 piles of blocks. And there are 3 layers of piles of blocks. Therefore, 3 times 6 times 3, it gives us 54 blocks. Each block represents 1 cubic unit, and if the blocks are placed in a box in which they just fit, the box will then have a volume of 54 cubic units. Let's have another example. If the length of another box is 6 units and its width is 5 units, how many units will form one layer? If there are 4 layers, there will be then 6 times 5 times 4, that is equal to 120 cubic units. The box is said to have a volume of 120 cubic units. Let's proceed to measuring volume. In studying volume, we'll be dealing with special figures such as the following: the width, the length, and the height. This is also referred to as a rectangular prism. The rectangular solid has 3 dimensions, namely length, the width, and the height. How many rectangles do you see? A rectangular solid has 6 rectangles which are called faces. Some examples of rectangular solid are the balikbayan box and other rectangular boxes, such as rice dispensers, refrigerators, and freezers. Can you give other examples of rectangular solids that you often see in your home and community? The cube is a rectangular solid whose dimensions are equal: the length, the width, and the height. Each dimension is called an edge. In the preceding figure, the cube has an edge of 9 cm. How many faces does it have? A cube has 6 faces which are all squares. Can you give some examples of cubes that you see in your home and community? A circular cylinder is another special figure. It has a circular base and sides that are perpendicular to the base. Examples of these are the tin cans of powdered milk, circular water tanks, and drinking glasses. How do we compute the volume of a rectangular solid? Volume is equivalent to area of one layer times height. That is, we talk the product of the length, the width, and the height. Thus, volume of a rectangular solid is equal to the length multiplied by the width and the height. Note that your answer should be in cubic units. In this case, the volume should be in cubic centimeters. Like for an example, the area of one layer, length times width times height, is equal to volume in cubic centimeters. That is 6 centimeters times 4 centimeters, that gives us 24 square centimeters, times 3 centimeters, that gives us a volume of 72 cubic centimeters. Another way of doing this is shown below. Volume times length times width times height, that is 6 centimeters times 4 centimeters times 3 centimeters, that gives us a volume of 72 cubic centimeters. Now, let us try solving some problems involving the volume of rectangular solids. Number 1. A rice dispenser is 3 decimeters long, 3 decimeters wide, and 5 decimeters high. What is the volume of a rice dispenser? Here's the solution. To get the area of the base, we need to get the length and the width first. The length is 3 decimeters and the width is 3 decimeters. Therefore, the area of the base is 9 square decimeters. Now that we know the area of the base and the height, we can now get the volume of the rice dispenser by substituting the appropriate values in the formula. Volume is equivalent to base times height. Therefore, volume is equal to 9 square decimeters times 5 decimeters. That gives us a volume of 45 cubic decimeters. Now let us try using the variation of our formula. Since in the problem, we are already given the length, the width, and the height, we can directly substitute the values in the formula. Volume is equivalent to 3 decimeters times 3 decimeters times 5 decimeters. That gives us also 45 cubic decimeters. For 7 minutes, try to solve the problems by using the formula in getting the volume of a rectangular solid. Number 1. A rectangular block is 5 centimeters long, 4 centimeters wide, and 3 centimeters high. Find its volume. Number 2. Tina bought a rectangular box of biscuits from the supermarket. The rectangular box was 12 centimeters long, 8 centimeters wide, and 4 centimeters high. Find its volume. Let's answer. Number 1. Volume is equivalent to 5 centimeters times 4 centimeters times 3 centimeters. That gives us a volume of 60 cubic centimeters. And for number 2, volume is equivalent to 12 centimeters times 8 centimeters times 4 centimeters. That gives us a volume of 384 cubic centimeters. Please compare your answers. We know that the cube is a special rectangular solid that has equal dimensions. So how do we solve for the volume of a cube? That is, the volume of a cube is equal to h to the third power, which means that volume is equal to h times h times h. The figure shown is a cube. Recall that in a cube, all the edges, the length, the width, and the height are equal. If we compute for the volume of the figure above with each edge equal to 4 centimeters, we will have V is equal to e to the third power is equal to 4 to the third power centimeters. That gives us volume of 64 cubic centimeters. Another example. What is the volume of a box that has an edge measuring 12 inches? Using the formula given, we have V is equal to the edge to the third power. Then that gives us 12 inches to the third power, and the volume is equal to 1,728 cubic inches. You're correct. Let's have another exercises. Number 1. A balikbayan box has an edge of 5 decimeters. What is the highest number of cubic decimeters that can be placed in the box? Number 2. Find the volume of a cubic wooden box that has an edge of 8 centimeters. Let's answer. Number 1. A volume of a cube, which is equivalent to age times age times age. By substitution, that is equivalent to 5 decimeters times 5 decimeters times 5 decimeters. Thus, the volume gives us 125 cubic decimeters. Number 2. Volume of a cube that has an 8 centimeters each age, that gives us volume is equivalent to 512 cubic centimeters. Let's learn about a circular cylinder. A circular cylinder is a special figure that has two circular bases and sides which are perpendicular to the bases. Recall that in getting the volume of a solid, we first get the area of one base and then multiply it by the height. And since in the case of a circular cylinder, we have a circular base, we get the area of the base using the formula. Base is equal to pi times r to the second power. Thus, following the formula for volume, we have the volume of a cylinder is equal to the area of the base times height. That is, base times height is equal to the pi times radius to the second power times height, where b is equal to the area of the base, the pi is equivalent to 3.14, the r means radius of the base, and the h is the height. Now that you know the formula for the volume of a cylinder, let us try solving a few problems. Sample problem 1. A can of orange juice has a radius of 3 centimeters and a height of 12 centimeters. What is its volume? Here's the solution. R, the radius of the base, is equivalent to 3 centimeters. The h, which is the height, is equivalent to 12 centimeters. The v, or the volume, is equal to bh, or the pi times radius to the second power times height. That is 3.14 times 3 centimeters to the second power times 12 centimeters. That gives us a volume of 339.12 cubic centimeters. Let's have another problem. Sample problem 2. Every morning, Kiko and Pong fill their cylindrical tank with water. Their tank has a radius of 5 decimeters and a height of 200 decimeters. How much water do Kiko and Pong fetch every morning to fill their tank? Very good! It's 15,700 cubic decimeters. How did you get the answer? Let's discuss. Where r is the radius of the base, 5 decimeters, h is the height, 200 decimeters, volume is equivalent to pi times r to the second power times h. That's give us 3.14 times 5 decimeters to the second power times 200 decimeters. Thus, the volume is 15,700 cubic decimeters. Correct! Yay! Congratulations! Let's have another exercises. Solve the following problems. Number 1. Candy was playing hide and seek with her friends. She decided to hide herself inside a cylindrical drum that had a radius of 500 centimeters and a height of 1,500 centimeters. Find the volume of the drum in which Candy hid herself. Another problem, number 2. Chris brought a sand bucket to the beach. The cylindrical bucket has a radius of 2 decimeters and a height of 3 decimeters. If Chris is to fill her bucket with sand, how much sand can the pail contain? I'll give you 7 minutes to solve the problems. Let us check your work. For number 1, we use the formula volume of a cylinder is equivalent to pi multiplied by radius to the second power times the height. By substitution, volume is equivalent to 3.14 multiplied by 500 centimeters to the second power times 1,500 centimeters. That gives us a volume of 1,177,500,000 cubic centimeters. For number 2, we use the same formula. Volume is equivalent to pi times radius to the second power times height. By substitution, volume is equivalent to 3.14 times 2 decimeters to the second power times 3 decimeters. That gives us a volume of 37.68 cubic decimeters. Have you ever wondered how things were measured in the past when there were still no standard units of measurement? Can you imagine just how people were able to build houses and other structures without knowing what meters are? How were kerosene, oil, and other liquids measured and sold at that time? You will find the answers to these questions in this lesson. Let's learn. Aling Sila has a sari-sari store. She always tells her customers that selling liquids like oil and kerosene was very hard in the past. Because back then, there were still no standard units of measure. Only the dangkal and dipa were used for measuring length. For measuring items like rice, corn, and other cereals, the ganta, litro, and otsaba were used. Have you heard of similar stories from your parents? The ganta and the litro were made of wood, while the otsaba or chupa was an empty can of milk. Now that we have standard units of measure, rice, corn, and other cereals are sold by the kilogram. 1 ganta of rice is roughly 2 kilograms. And litro is 1/3 of a ganta. Look at the indigenous measures of volume again. If a litro is 1/3 of a ganta, how many litros are there in 1 ganta? If you say 3 litros, then you are right. Our grandparents would usually express it in Spanish as 3 litros. You could probably ask your grandparents about other units of length and volume which our great-grandparents have used in the past. The ingenuity of the early Filipinos should be appreciated, especially by the younger generation. Their resourcefulness and initiative contributed a lot to the kind of life they had. The use of dipa, dangkal, ganta, and other measures shows us how resourceful our forefathers were. Even in the early stages of our history, Filipinos already engaged in trade, which was known as the barter system. They exchanged goods for other goods with no money involved. They flourished even with the use of indigenous measures of volume. Today, Even though we already have standard units of measure, some people who live in places where there are no weighing scales still use the indigenous system of measures. They still use biscuit cans for measuring amounts of palay. They use lapad for measuring oil. They use takal for selling salt, munggo, and corn. But what do you think are the disadvantages of using indigenous measures? If you say that these units are not accurate and measurements based on these units are not precise, then you are right. If one uses an indigenous measure, there are more chances of making mistakes because the measurements are not accurate and precise. Example of indigenous measures of volume. Mangkok. That's bowl in English. Takal. That's tacos in Cebuano and Boholano. And that's sukat in Tagalog. Dilapad. They use lapad for measuring oil. And they use litro to measure gasoline or kerosene. We have also the bucket or balde. This is used to hold or measure a liquid like water. But now the measurement used is in gallon. Another one is the ganta, or the so-called gantangan in Bisaya or gantang in Tagalog. What is volume? Volume is the amount of space any form of solid or liquid matter occupies. What is the formula in finding the volume of a rectangular solid? Very good! The formula in finding the volume of a rectangular solid is equal to the length, the width, and the height. What is the formula in finding the volume of a cube? The formula of a volume of a cube is equal to the h to the third power. What is the formula in finding the volume of a cylinder? Very good. The formula of a volume of a cylinder is equal to pi multiplied by the radius to the second power multiplied by the height. Name some of indigenous measures of volume. Would you recommend using these measures? And why? Very good. Some of the indigenous measures of volume used were takal, mangkok, lapad, litro, bucket, and ganta. Very good! Some of you answered no. Why? It's because it will not give you an exact, an accurate, and precise measurement. Answer the following problems. Write your answer on your activity notebook. For Group 1, solve the following. Number 1. If a picture has a base area of 15.7 square centimeters and a height of 5 centimeters, how much water can it contain? Number 2. How are the items below measured? In the past and in the present. Number 1, rice. Number 2, salt. Number 3, palay. Number 4, coconut oil. Number 5, kerosene. For group 2, solve the following. Letter A. A water tank is cylindrical. The radius of the base is 5 meters and the height is 10 meters. Find the volume of the tank. Letter B. Write the best unit of measuring the volume of the following items. Number 1, balikbayan box. Number 2, gasoline. Number 3, swimming pool. Number 4, aquarium. And number 5, shoebox. Let us now proceed to your activity sheets. For 10 minutes, answer your activity sheets. For 10 minutes, answer the following questions. Why it is important to know how to compute for the volume of a certain objects. Number 2. Does some people in your community still use the indigenous materials in measuring a certain things or objects, and why? Let us check your work. For number 1, it is important to know how to compute for the volume of a certain objects because it can help us to determine the amount required to fill that object, like the amount of water needed to fill a bottle, and aquarium or a water tank. For number 2, some people in our community still use the indigenous materials in measuring a certain things or objects because there are still some places where there are no weighing scale or any standard units of measurements. Any questions? If there's none, then let us proceed. Assignment. Name some indigenous measures of volume. Number 2. Would you recommend using these measures? Why and why not? Thank you for attending our class and hoping to see you all on our next schedule. Thank you.